Welcome learners for the lecture second of a differential geometry. Okay, in the first lecture we introduce all the parts that will be generated to the form, that is the definition of a surface. They represented as a two form, what is the content of the differential geometry, as well as to the form of the introduction part, how to generate it as the surface in this equation. Okay, some example will be given in this second lecture. Okay, let us go started as the form. Example first will be generated. The parametric equation of a surface are not unique. To see this, we produce a surface having a two different parameter representation. Okay, fine. First of all, we generated as a plane. Clearly show that how to surface will be represented. One surface will be given to the form, that is a plane surface getting to the point P on this surface, and this point will be generated to the form x, y, z axis. This axis will be considering as a form, that is the different parametric representation of the surface. Okay, now consider the following two sets of a equation. First set is x equals to u plus v, and this is a representation by using as a domain uv, and xyz is represented as a globally representation on a surface. X equals to u plus v, y equals to u minus v, and z equals to 4uv, and x equals to u, y equals to v, and z equals to u square minus v square. This is the two sets. Okay, eliminating the parameters in the both of the representation of this form, that is the constant equation is generated to the form x2 minus x2 equals to z, which is represented as a whole of the certain condition hyperbolic parameter will be uses in this form. Okay, this hyperbolic parameter will be generated to the form of the representation, that is the x2 minus x2 equals to z will be represented. Okay, second example will be given, that is a sometimes the content equation obtained by eliminating the parameter represent more than the given surface. To see the parameter will be uses as the considering of the form, that is the trigonometric form will be generated. X equals to u cos hv, y equals to u sin hv, and z equals to u square for the real value of the function. Eliminate u and v among the equation. The constant of the equation will be generated the form, that is a x square minus y square equals to z. The constant equation represented as a one of the hyperbolic paraboloid, while the parametric equation given only the part of the hyperbolic paraboloids. For given to the value z is always greater than or equals to 0. How to consider as a z, that is a x square minus y square will be considering. If we greater than or equals to 0 means a 0 is less than, x is greater than means value will be generated upper than to the 0, that is a 1 2 3 4 5. Okay, this value given to you takes the only real value. This real value will be generated to the form. Definition third of this surface of this form will be generated as a form. Let there be the two parametric representation u and v, and u dash v dash of the both same surface. In it, transformation of the form, that is a u dash equals to phi uv and v dash equals to xi uv, relating these two representation is called as a parametric transformation. Okay, this will be the form is a generated. Okay, form will be generated u dash equals to phi uv, v dash equals to xi uv, relating these two representation is called as a parametric transformation. Definition 4 will be generated. A parametric transformation is said to be proper if phi and xi are a single value function. Definition 4, a parametric transformation is said to be proper if phi and psi are a single value function. Then second will be generated. The Jacobian form is also using to the proper function of the delta will be generated as a phi and psi upon phi of a delta consider as a u and v is not equals to 0 in some domain. This is also definition, all of this considering in the form of the, that is the surface will be used.